Hey guys, we're going to do part D in this video, but before we do, I noticed I made a mistake in the last one, so let me correct that. I just wrote this R here, when in fact we already replaced that, so that was silly. I will delete it. The other thing is I checked the notes, the answer notes, and the solution that they have for the k dot is this one here. And there's no delta because in the solution set they didn't put a delta in the rental rate function. They just said that big R equals little r. And I didn't really see anywhere in the problem that said there's no depreciation, so I kind of think that's incorrect, so I left mine in. But I really don't know how they got rid of this 1 here. And maybe somebody can see it. I looked at it for a while, and I can't figure it out. So if you can figure it out, let me know. Maybe I'm right, maybe I'm wrong. Anywho, let's do question number D. So in question D, we're told that there's 2 islands. Island A has capital stock under the steady state, and island B has half of that stock. And there's a story about people coming, but that's not important. So we're going to draw the phase diagram, and we're going to say how are the islands different, if they are different. So let's draw the phase diagram. We'll do it in red. We have K on the x-axis and C here. The consumption function is always a straight line. You can check the shape of these functions. I don't know if it's possible to trick us, but if you just plug in 0 equals all that and then solve for K, you'll find that it's just equal to a flat parameter. It looks like it'll be like delta plus rho divided by all of this here, alpha times 1 minus tau. So that would be the value of K star. K star. And then C star, you could also figure that out by putting in 0 for this one, for the K function, C star. Okay, so we're told that there's an island that has some K that's below K star. So let's say that K is right here. And we'll pick a point and say this is K0. And then there's another island which has half as much of that. So let's say that's here. And let's make this K0. K0. And the question is, are these on the saddle point path or not? And the answer is yes. A starting point for this model is always going to be on the saddle path, because in fact for every K there exists one C0 that can pair with it and put it on the saddle path, no matter what that K is. So you see you have that straight line. For every single K on this line, we can pick a C that will put us on the saddle path and will get you to the steady state. So I think one thing that was kind of lost in all of the discussion in class about, there's only one and you got to find it and it's really difficult. It's difficult for us in the real world as planners to find it. But in model world, the people that we're modeling will always choose their C correctly. So don't think of them as people, think of them as these, they're like robots that are using these functions. So whatever the answer is to this function, they know it by the logic of the model, and they're going to put themselves on it. Yeah, so the first person is going to start here, the second person is going to start here, but in the end, they're both going to evolve to the steady state point. And there might be a way to know if one goes there faster or not. I'm not actually clear on the convergence mechanics of Ramsey. I didn't go that deep into the book, but if you did, I guess leave a comment. Smash that like button, guys. Anyway, I'll see you in the next video for the last question in this problem set.